So we'll just start a lesson in areas and parallelograms. So what is a parallelogram? So its opposite sides are parallel to each other. First we will see what is this when these two figures are congruent. So two figures are congruent. What is meant by congruent? If they have the same shape and size. If the size and shape are same, so they are congruent. So two figures, what is it? See, if we just take a triangle, we can compare with another triangle. So each the shape should be same, each side should be same, angle should be same. Then only the two triangles are congruent to each other. So if it is a square, so if it is a rectangle, by area these two may be equal, but this is a square, this is a rectangle. So they cannot have the same size, they may have the same area. In rectangle means one side is A, another side is B. Square means both sides are equal. So they cannot be compared. So we will take some more shapes, we should suppose say this is an hexagon. So we can compare with only another hexagon. So should have the same shape. And when they say same size, the length, this length of the sides, should be equal to each other. And also the angle. So corresponding sides, all should be of same shape and size. So two figures are congruent if they have the same shape and same size or length. So now we will come to parallelograms. Now two figures are said to be on the same base and between the same parallels if they have a common base, and the vertices opposite to the common base of each lie on a parallel to the base. Suppose just we'll take two figures, we take a triangle. Suppose there's another triangle here with the same base, if the vertices, if they are parallel to the base, so what we call it same base and between parallels. What do you mean by? Suppose the base is AB and this vertex is, this is C and D. If AB is parallel to CD, the vertex is CD is parallel to the base, then these two figures are said to be on the same base and between the same parallels. Because we are dealing with parallelograms, we'll be dealing these six ways. So we know parallelogram is for these two, the opposite sides are parallel and equal to each other. So we'll go now next go to the theorem. parallelograms on the same base or equal base and between the same parallels or equal in area. So what is the base here? Now AB is the base. So we may have one parallelogram ABCD, another parallelogram ABEF. To AB is parallel to DE. Then area ABCD is equal to area ABEF. Parallelograms on the same base or equal base and between the same parallels are equal in area. So, we will approach this problem, So we will take a square. Okay, we will take a parallelogram. On the same base. So what is the area of the square? It is simply the base into this height. So area is equal to BH. What about the area of the parallelogram? So we will take it as parallelogram. This is ABCD. Area of the parallelogram also. Area of parallelogram we call it. That is also base into the same height. So actually we can cut this triangle and put it here just like that. We can prove that these two triangles are equal in area. Base into height. Parallelogram means base AB is equal to CD. Height is common between these two. Area of the parallelogram also is equal to base into height. So in a similar way, any other parallelogram. So we can have, see, you try to draw one more parallelogram. So make it little steeper this way. Here also make it little steeper, except this line. So this new parallelogram, the second parallelogram is of same area, base into height. So what is the basic? We'll go to the theorem. Parallelogram on the same base or equal base and between the same parallels are equal in area and is equal to base into height. So we'll go to next theorem. So we'll do a small problem. In the figure ABCD is a parallelogram. AE is perpendicular. Now AE is, this is perpendicular. This angle is 90 degrees perpendicular to DC and CF. Now CF is, this is also perpendicular. If AB is equal to AB is equal to 60 centimeters, and CF equal to 10 centimeters, and AE is equal to AE, perpendicular is 8 centimeters, perpendicular. So find AD. So we will simply write now area of the parallelogram ABCD is equal to base into height. What is base? Base is 16. If AB is 16, the CD is also base into height. 16 centimeter into 8 centimeter is the area. So we'll see, we'll take the ADS base and you see what is its height. Now what's the area? Same area ABCD. What is the base? Base is AD. AD we have to find out. This AD is the base. AD multiplied by, now CF is base into height. CF is 10 centimeters. So these two are equal. AD is equal to 16 multiplied by 8 divided by 10 is equal to 128 by 10, or is equal to 12.8 centimeters. But ABCD is a parallelogram, so we can take AD. If we take AD as a base, CF is its perpendicular distance, base into height. Same formula will hold good for this also. So we'll do next problem. We'll go next problem. So ABCD is a parallelogram as shown in the diagram. If E, F, G, H are respective to the midpoints of AB, show that area EFGH is equal to half of area ABCD. Now, these are all midpoints. We know AH is equal to HD. Now, DG is equal to GC. Same parallel here also. These are all equal. Now, so what we have to say, this HF is parallel to AB and DC. How? ABCD is a parallelogram and H and F are midpoint. So AH by HD is equal to BF by FC is equal to 1. So the distance between these two lines is same. Therefore HF is parallel to AB and DC. So distance between these lines, between these two lines AB comma HF are same. So we can do this problem in two ways. When HF is the base, so taking HF as base, so we have got, so parallelogram ABFH is equal to 2 times the triangle, 2 times the triangle area. Sorry, this is taking HF as well, area of the parallelogram. This is area of the parallelogram ABFH is equal to area of twice the triangle AEF. how area of the parallelogram is base into height, same as twice area of the triangle is half base into height. So in a similar manner, with the base as hf, if you look downwards, area of the parallelogram HFCD is equal to twice the triangle HFG. If you add these two, this is area of the parallelogram ABCD is equal to twice the area of HEFG parallelogram. This is a parallelogram. If you add these two triangles, you get a parallelogram. Parallelogram, and with HF as the chord. Or if you split into, so another way of proving is, see this AEH, and if the point is taken as O, this is a parallelogram and this is a diagonal. So these two areas are equal. So these two areas are equal. So the parallelogram is equal to twice the area of this H, this 1/4. If you add all that 4, if you add all these 4, and these 4 are equal. So that way also you can prove it. So let's go to the next problem. ABCD is a parallelogram and P and Q are any 2 points lying on the sides of DC and AD. So we are show the area APB is equal to area BQC. So this P can see, now note this P comma Q can be any point on the line DC or AD. See, when base is AB, whether P is here or P is here, area of the triangle between two parallel lines is the same. So how we go? It's very simple. Area of the parallelogram ABCD is equal to 2 times the triangle area of the triangle. We will write 2 times area of the triangle ABP, because same base AB. Instead of writing area, we'll just put AR, area of the parallelogram ABCD. So what about this way? If you take BC as the base, because you are got a triangle area BCQ or BQC. So this BC, now taking BC as the base in this first problem, you are taking AB as base, you are taking. Next problem, so taking BC as base, same area of parallelogram ABCD is equal to twice area of the triangle BCQ. that is equal to twice base into height. This is base multiplied by height. That is base is BC. Base is common, both. So area of the parallelogram ABCD this way or that way, both are same. Hence, area of the triangle ABP is equal to area of triangle BCQ. BCQ is 2. So this is 1. From 1 and 2, we are at 3. So we'll go to next problem. So in parallelogram, we have got a special property. You know? See in figure, next problem you see, P is any point inside the parallelogram. You are just joining the P is any point. You just joining PA, PB, PC, PD. So we will do a construction, you know. We just draw a parallel line EF. Draw a parallel line EF to AB or CD. If you draw these two are AB and CD are parallel. If you draw a parallel line EF, that's parallel to both these lines. So what is that to prove now? Show that the area PBP, PB, AP, sorry, is APB plus area PCD is equal to half the area of ABCD. It's very, very simple. Same problem as before. Taking AB as the base. Now, taking AB as the base. You know, area of the parallelogram ABFE is equal to 2 times the area of the triangle ABP. Similarly, area of the parallelogram DCFE is equal to twice area of the triangle DCP. So the area of the triangle, if you write this way, that way also is fine. If you just add these two, so we get area of the parallelogram ABCD is equal to 2 times area of these two triangles ABP plus DCP. So to parallelogram, we write just like this. This one GM, we write parallelogram just to save space. Parallelogram so what we have learned, so now we will go back to the first theorem again. Parallelograms on the same base or equal base between the parallels or equal in area. If there's a triangle inside the parallelogram, then it's half the area of the parallelogram. So we can so area of the parallelogram is equal to base into height. So the next problem we find, so we have just see some of the properties of the parallelograms. If we know one side, we can find out the other. So what is the property of the parallel? When suppose two parallel lines are there, when we draw another line of with equal distance, that line also is parallel to both these two lines. So this is the basic property of the parallelogram. So we will see more problems in the coming lesson. So we will first should know about what has been made congruent, same shape and size. So we cannot compare a square and a rectangle. So shape and size should be same, or even a triangle means this angle also should be same. All the corresponding angles, corresponding sides should be equal if two figures are congruent. So thank you for listening to this lesson. Please repeat the problems and try to understand the basics. If you have got any question, please write to us. By repeating 2-3 times, certainly we will be able to understand the basics of the problem. Thank you once again.